L'Hopital's rule, example 2, part B. We're taking the limit of a fraction, which opens up the possibility of L'Hopital's rule. But again, we want to check to see if we have one of the two indeterminate forms. X is approaching infinity. Infinity to the third power is indeed going to be infinity. Infinity plus 9 is still infinity. The point would be if you have an x up here and you're going to put infinity in, that's going to be infinite. So yeah, yes, I would agree that this would be considered indeterminate. And so therefore, you guys probably already have the answer because you know the shortcut. But I love L'Hopital, I'm going to do it. So yeah, that's indeterminate. So let's apply L'Hopital's rule here. So this would be 4x plus 12x to the third power minus 7. Oh, look at that. The minus 1 fell out, didn't it? These terms are going to disappear. This will be 15x squared minus 4, and the plus 9 has a derivative of 0, so it basically doesn't matter. Ultimately, does it? Those two terms ended up not really mattering, did they? If you think about it, when x goes to infinity, these little constants hardly have any effect on that fraction at all. That's the idea behind it. All right, check for, see if you can cancel. And I don't know how you would even factor anything here. Let's try infinity again. Infinity squared is infinity. 4 times infinity is still infinity. Hey doc, I'm indeterminate. Can I get more L'Hopital? Yeah. I'll prescribe L'Hopital again. Let's see, I guess we'll do it down here. It's still indeterminate. It's appropriate to apply L'Hopital's rule. That would be 4 plus 36x squared. Minus 7 goes away. Minus 7, by the way, came from the negative 7x. Clear back here if you track back. That term ends up not mattering. And down here we have, what do we have? 30x, and the minus 4 disappears. And minus 4 came from negative 4x. That term, after 2 applications of L'Hopital's rule, ultimately fell off, if you will. And let's see, could we cancel x's here? No, because of that plus. I still don't think there would be some easy cancellation going on here. So let's see, what's 30 times infinity? Infinity. What's infinity squared? Infinity. Is it still indeterminate? Yep. So we move on. Limit as x approaches infinity, we give it another dose of L'Hopital. Yep. Patient is still indeterminate. 4, that goes away. Let's backtrack. 4 came from 4x, which came from the 2x squared. That term ends up not mattering. Alrighty. And the numerator has a derivative of 72x. And the denominator has a derivative of 30. Notice that denominator is a constant now. That denominator is not going to become 0 or infinity, is it? It's 30. Okay? So, how's the logic follow from this? That's 30. There's no x's anymore. That's not going to go to infinity. It's not 30x, it's just 30, isn't it? If you put infinity in for x up here, the numerator is infinity. All right, now, that's weird looking. What's infinity divided by 30? How many times does 30 go into infinity? Infinity. All right? Is that what it is? Infinity divided by 30? Yeah. So wouldn't that be infinity? Okay. Now, what's going on with that? Well, this was that situation where, if you go back to the shortcut we learned earlier, the largest power of x was 4th power. And so the idea was that the numerator had a coefficient of 3, the denominator had a 0, and 3 divided by 0 does not exist. You might remember that when a limit comes out to be infinite, that also means the limit does not exist. And that would have been the quick interpretation we would have gotten if we'd have used that coefficient idea that we did on that assignment long ago. So anyway, there's multiple ways to get there, but to me, that worked. I hope that all made sense.